Alright, so for number 2, we're going to be graphing some, well, for 2 through 6, we're going to be graphing some quadratics and then comparing them to the parent function y equals x squared. So in number 2, a is -1, that's the number here, and k is 5. So a and k, remember, affect the y, not the x. So that's why right here in pink I put -y plus 5. Because a is -1 and k is 5. So I'm going to transform the points now so I get, remember the x's don't change. The opposite of 1 is -1 plus 5 is 4. 0 plus 5 is 5. And then the opposite of 1 is -1 plus 5 is 4. Okay, so those are the points that we're going to graph. So plot -1, 4, 0, 5, and 1, 4. Okay, you can add a couple of points if you like, but to make it extend it down a little bit more, so if x was 2, -4 plus 1 is 5. I mean, -4 plus 5 is 1. So right here, and the same thing would happen with -2. And you go down and down. They want you to compare this graph with the parent function, so you would just say something like it's reflected or reflects over the x-axis, and it moved up 5. So in number 4, the h is -1, because remember it's x minus h right here. The a is -1, just like in the previous problem. So you could see here how a and h are going to transform your reference points. So the x's are going to decrease by 1 and the y's are going to change signs. So that gives you -2, -2 and then -1, -1, 0, and 0, -1. Okay, so we plot the points -2, -1, -1, 0, and 0, -1, and just continue the graph. So to describe the transformation or compare it to the parent function, we would say it's reflected or reflects over x-axis, and it moved one unit to the left. Okay, so for number 6, a is -1 right here, h is +2, and k is also +2. So I already showed the transformation here, what's going to happen to the reference points. X's are going to increase by 2 because h is +2, and y's are going to change signs, and then we're going to add 2 to them. Okay, so I have 2 minus 1 is 1. Oops. And then the opposite of -1 is 1. 1 plus 2 is 3. 2 plus 0 is 2. 0 plus 2 is 2. 2 plus 1 is 3. The opposite of 1 is -1 plus 2 is 1. -1 is 1. Doesn't make sense. Oh, oops, sorry. Just realized that I used the reference points for the, I'm like, does that make sense? It shouldn't, because these are the reference points for the cubic function or cube root function for either one. So I went ahead and I changed the sign to +1. So then this here should be a 1. Oops, right there. Sorry about that. Alright, so let's go ahead and plot the points. So I have 1, 1. I had to fix that one because I used the wrong reference point. So 1, 1, 2, 2, and 3, 1. And just connect the points down and down. Okay, so how this compares to the parent function, it reflects over the x-axis, and it moves to right and to up. Alright, for number 8, they want you to describe the function, identify the vertex, sketch it, and if there are any x-intercepts, to identify them, right? So I know that this parabola opens up. The vertex is 4, 4. I'm sorry, 4, negative 4. Let me fix that real quick. 4, negative 4, because h is positive 4 and k is negative 4. Right here. H is positive 4 and k is negative 4. So now I'm going to sketch it. So I'll start out by plotting the vertex 4, negative 4. Because it goes, the A is 1, I know that it goes right 1, up 1, so I have a point there and a point there. I could plug in a 2 for x, so it gives me negative 2. When you square it, it's 4, and 4 minus 4 is 0. So I know that the same thing is going to happen over at 6. 6 minus 4 is 2. When you square it, you get 4. 4 minus 4 is 0. So we got lucky on this one where our points went through the x-axis right at integer values. So I know that, my x-intercepts are 2, 0 and 6, 0. Alright, since number 10 is not in vertex form, I'm going to use a formula for finding the vertex. Remember, x equals negative b over 2a. That gives me the x-coordinate. So the opposite of negative 12 is 12, the opposite of b. And then 2 times 3, that's 6. So 12 over 6, that's 2. To get the y-coordinate, replace all your x's with 2. So I get 3 times 2 squared minus 12 times 2 plus 11. So that's 4 times 3, 12, minus 24 plus 11. So that's going to give me negative 12 plus 11, which is negative 1. So the vertex is 2, negative 1. And with that, I can rewrite the equation f of x equals a is 3, x minus 2 squared minus 1. So this would be the same equation in vertex form. Okay, so now I'm going to plot it. So the vertex is 2, negative 1 right here. And because a is 3, I know that it's going to go to the right 1 and up 3 units. So 1, 2, 3. And left 3 units. Left 1 and up 3 units. So I connect the points. Because there's a vertical stretch, the graph looks skinnier. Okay, so it's going to intersect the x-axis in 2 places, but not in integer values, so that means I'm going to have to use quadratic formula. So here you see the quadratic formula. This is going to give me the x-intercepts. So again, replace your ABC. So the opposite of b is 12, plus or minus. Negative 12 squared is positive 144, minus 4 times 3 times 11, all over 2 times 3. So 12 times 11 is 132, so I get 12 plus or minus the square root of 144 minus 132 is 12. And I know that 12 can be simplified as, because it's 4 times 3, so it's, so it's 12 plus or minus 2 radical 3 over 6. Remember, you do not cancel like this. You do not reduce like this. You have to factor out a common factor. So in the numerator I have 2. And then here I keep the 6, so I can reduce like that. And so I have 6 plus or minus radical 3 over 3. These are my two x-intercepts. So that's these value, the value right here and the value right here. Okay, so I just did a rough sketch of what they gave us. The vertex is 2, -1, and another point on the graph is 5, 2. So this parabola is going to open up. So I expect an A value, a positive A value. So I wrote down the vertex form of the parabola or the quadratic, and so we're going to substitute the numbers in for the variables. So y, remember the xy is this point right here, so this is x, this is y, and the vertex will be your h and your k. So 2, just substitute, so x is 5 minus 2 squared minus 1, because k is -1. So I'm going to add the 1 to both sides. So 3 equals, now here I get 3, but then I'm going to square it, so that's actually 9a. So I'm going to divide by 9. So a is 1/3. So when you write your equation, you could write y equals 1/3 x minus 2 squared minus 1. Okay, for number 14, we're looking at a 3-section skating rink, portable skating rink, and they want to maximize the skating area. So they want to maximize this area. All you know is that each rink is x units wide and y units long. You have 1,500 feet of boards, and you want to maximize the area. Okay, so we're talking about two things. We're talking about length, because we have 1,500 feet of boards, and they also talk about area. So let's go ahead and set up equations for what we know. So I know that I've got x here, so I also know that this is x, right? Because they're the same measure, and then I know that these are y's. So I have a total of 6x plus 4y. That's going to equal 1,500 feet. Okay, because that's a total, that's just the sum of all the boards, right? So 6x plus 4y equals 1,500. I can make this equations with smaller numbers if I want. I can divide everything by 2, so this will be 3x plus 2y equals 750. So I'm going to keep this equation right here. Another thing I know the area for the formula for the area of a rectangle, right? So if I look, and I'll use a different color, I want to maximize this area, right? Total area. So I know that the dimensions of that rectangle, so for that area, are 3x, because I have 3x right here, times y. Okay? So I'm going to use, I have a system of two equations right here, so I'm going, and I notice that right here I have a y that I can solve for, and I could substitute it in here, so that I could have an equation for the area in terms of x. Okay, so I can eliminate one of my variables by solving for y in the first equation and then substituting. And that's what I'm going to do in the next step. So let me subtract 3x from both sides out of this equation. So I get 2y equals -3x plus 750. Then I'm going to divide by 2. So I get y equals -3x over 2, and I'm just going to separate them because I noticed that I can divide 750 by 2, so it's going to give me 375. Okay, and so I have y equals -3x over 2 plus 375. So I'm going to take that and substitute it here. Okay, so